Good day to all. Today we are going to discuss the quiz 4, which is about the physical properties. In this class, we have discussed some physical properties such as density, compressibility factor, specific gravity, specific volume, viscosity, and this type of the properties. And in this class, we'll discuss some questions and also give some basic explanations to the questions, like in terms of the practical side view. Let's start. The first question is, we have approximately 9 questions. Yes, 9 questions. The first question, meter cube over kilogram is the unit of what? So first of all, let me open the page. As you know, or if you are confusing it frequently, kilogram per meter cube, as you see, M over V, mass over volume, is rho, which is density, right? And in the question, it was asked to find meter cube over kilogram. It means this is 1 over rho. 1 over rho in engineering as a physical property, we say that this is nu, which is specific volume. In some thermodynamic graphs, you can also see charts. You can also see density or specific volume values. If it's like asked to find the density and you're given with a specific volume, you will just divide 1 over nu, you will find the density, or you can do it vice versa. This is the first question. Next one, specific volume. The second one, specific gravity of the given fluid is 0.71. What is the density of this fluid? So specific density is given. Briefly, this is like named as SG, specific gravity. This is equal to density of given fluid over density of water. So density of water is accepted as, at normal conditions, 1000 kilogram per meter cube. This is unitless factor and it was given like 0.71. It means that we need to multiply this specific gravity by the density of volume and we'll get approximately, no, exactly 710 kilogram per meter cube. So let's see if we have any answer like this. Missing information? No, we can find it, 710. Next one, increase in temperature rises the X viscosity due increase in kinetic energy, which cause more chaotic movement. What is X? X is a state of matter. First of all, the first keyword is like X is a state of matter. State of matter are gas, liquid, and solid, right? Next one. The second keyword that I am looking for, this more chaotic movement. As we know, so in the gases, we have chaotic movement. The collisions of the particles, collisions of the molecules, they can create the chaotic movement. That's why it will be gas. So let's make sure ourselves that, is it true or not? Increase in temperature rises the X viscosity. It's correct. When we increase the temperature, viscosity of the gases are also increasing. Due to increasing kinetic energy, that's correct because the collisions of the molecules are increasing as well. This will be gas. What was the most viscous fluid? So the honey, no. Oil, no. Wax, no. Asphaltene, bitumen, or peach drop, we say that they are the most viscous fluids. But peach drop are more preferred and the most viscous fluid during this like chemical engineering lifetime. Next one, convert 100 Celsius into Kelvin scale. If you have already watched our video about the conversions of the units, so we have discussed it, like if you want to convert from the Celsius to Kelvin scale, you need to add 273 or 273.15 and it makes like plus 100. Right here, it will be 373 Kelvin. Next one, if Reynolds number is 8000, what is the flow regime? Let's write it here. First of all, we have different like flow regimes, right? The first one is laminar. Second one is transient. And the last one is turbulent. So if Reynolds number, and we are determining our flow regime with the help of Reynolds number. If Reynolds number is less than 2100, or in some textbooks, it's also given 2000 or 2200, So make sure that your textbook what's required, and you also know that value. The next one, turbulent, Reynolds is greater than 10,000. And between these two, let's write 2,000 and Reynolds number between 10,000, it will be transient. And in the question, it was given like 8,000. That's why we say this is transient region. Next, image for 2 questions. Okay, for water ice melts at Tm. As you see, this is Tm melting point, Tb boiling point. So these are phase transition temperatures. First of all, this is the thermodynamic property that we need to learn about. This is enthalpy and temperature relationship graphics, right? First of all, this is solid phase. Let's say this is ice, and it tries to heating up and reaching its T melting point. As you know, ice is melted at 0 Celsius. And the H1 between these two, T1 and Tm, it will be sensible heat. We said that in our previous class. So the sensible heat is trying to changing the temperature in order to reach the different phase of the state of matter. So it's not like changing the phase of state of matter. No, it's like reaching that state. So as you see, this is solid at the beginning of the process, and at the end of the process, it will be liquid, trying to get like liquefied. It's trying to melting here. In delta H2, it will be latent heat because here our phase change will happen. So as you know, ice will be melted during this change, during this delta H2 at this constant temperature, and it will be liquid, you can see here. So next, Tm to Tb melting to boiling. As you know, this is again liquid is trying to get heated up, and we are reaching like delta H4. So this liquid again will be vaporized. This is delta H vapor, which is with a heat of vaporization, and latent heat again at boiling point at 100 Celsius. And after that, we have the superheated region we are not interested in right now. So let's see what is asked. I've shown in figure above what is type of heat is given in range of H2 to H3. H2 to H3, this region is asked in the question. It's like the delta H2. From H2 to H3, this is the delta H2. We said that we have 2 types of the heat, which are sensible and latent heat. And the phase change happening in that parts, in that constant parts, which is the latent heat. We need to write latent. As shown in figure above, what is the correct equation to find the third enthalpy value? The third enthalpy value is here, right? And we said that we have the temperature change, it will be sensible heat. So in order to find the sensible heat differences, we are like using the integrated form of Cp, heating value, from T1 to T2, which is lower limit is Tm, T melting, and upper limit is Tb, boiling. Let's see where do we have this type of the equation in the question. And we need to consider as well what is the state of matter, what is the phase here. So this is solid, this is already liquid, this is already gas. It means that we need Cp liquid from Tm to Tb and integral form. Let's see, not this one, this is the first, delta H1. Cp vapor, no. Yes, this one, Cp liquid from T melting to T boiling. The C is the correct. So the next question, looking at this figure below, vacuum pressure is given 72.5 bar gauge. It should be kilopascal, if I don't mistake. Find absolute pressure, use reference points given on the diagram. Okay, you see this diagram. We said that the atmospheric pressure is taken as 0 if you want to measure the gauge pressure. If you want to measure the absolute pressure, you need to also consider the absolute vacuum, the 0 bar A, okay? And also don't make mistakes. In absolute pressure, we are considering this is bar absolute A, and in gauge pressure, it's bar gauge, bar G, it's written. And additionally, if it's we have 2 types of the gauge pressure, positive and negative. The positive will be positive gauge pressure, but the negative is mainly called like vacuum pressure, and it's below atmospheric pressure. So the general equation, it's written in this way. P absolute is equal to P gauge plus P atmospheric, right? And we know that P atmospheric is 101.325 kilopascal. And gauge pressure, it was given as 72.5, right, kilopascal. So as it's given like vacuum, we need to consider its sign as well. It's negative sign because it's below the atmospheric. And we need to take the sum of these values. It will be P absolute. So let's open the calculator. 103.5 minus 72.5. Yes, it's 28.825 kilopascal. Okay, so in the question, it was like given in a wrong way in terms of the unit. It's asked to find with the bar A, bar absolute. If you write like bar gauge, it will be wrong because it should be bar A in terms of the absolute pressure. Hopefully it's clear. Let's go back and let's see what are the answers. So this is also confusing because you can also take the sum of them, but it's not the case because it's asked to find the with vacuum pressure. If it's like positive, you need to take the sum of them. Okay, this one, yes, this is the correct. The variant 28.825 bar absolute. It's our correct variant. That's all for today and the quiz 4. In the next lesson, we'll discuss the quiz explanations about the introduction to chemical process and material and energy balance. That's all. See you.